Yeah, I just want to do the same invitation to builders to go and check all these amazing tools that we are building and that other people are building to make NFTs much more powerful, and for holders and agents to ask for their collections, to look for innovation in what they are buying, and to literally ask the owners of the collections to move forward, to not stick to 721, which, yeah, it's great, but it can be a lot more than that.
NFTs are one of the most popular blockchain applications. Building standards around NFTs will facilitate many Dapp developers to come up with mind blowing projects. If you are into learning new Ethereum standards, continue listening. Welcome to PEEPanEIP episode 109. I'm Pooja Ranjan, back with another interesting Ethereum standard for NFT projects. ERC-6059, Parent Governed NFT, was documented in November 2022. This EIP has been added as an Ethereum standard in April 2023. I'm excited to welcome back Stephen Pineda and Turk from Team RMRK to talk about ERC-6059. Thanks for joining us.
Hi, thanks for having us.
Really nice to be here again, Pooja. Thank you.
Very well. For people who missed, we have recorded an interesting conversation with the team on ERC 5773 context dependent multi asset tokens. Don't forget to check out the recording on ERC playlist at EthCatHerders YouTube. Moving on to today's topic, I can't wait to learn about this NFT standard. But before that, may you briefly introduce yourself to our new listeners?
Hi, I'm Jan Turk. I'm one of the co-authors of ERC 6059. I've been building Solidity smart contracts and researching blockchain and possible implementations since 2016. And I really just do blockchain for fun and for my job. So it's really my life.
Hey there, I'm Steven. I don't have as much experience as Jan, but I've been doing specifically NFTs for the last almost 2 years, and I've been looking for ways to expand the technology with these protocols and to find new use cases, and yeah, basically to expand the knowledge and to expand the possibilities of NFTs. I hope you enjoy this and the other ERCs that we've proposed.
Thank you so much for your introduction. And without further ado, let's peep in.
Hello. So first off, ERC 6059, parent governed nestable non-fungible tokens. It's a mouthful, but it really sheds the light on what this proposal is. So about us. So we are tackling NFTs 2.0, the next generation of NFTs, because currently the NFTs are images, videos, music, or, a lot of other things, which ownership is secured on blockchain, and they can be uniquely identified and traded frictionlessly throughout the ecosystem. So the problem that we are tackling is that most NFTs today are static. So not in the sense that the content that they're holding is not moving or is not changing, because there are animations and videos and music attached to them, but that they are not changing or they are not adapting to where they're being loaded and how they're being used. So they cannot evolve any further than at its current state. And what we at RMRK did was take a look at how we can improve NFTs, what utility we can add them. And we broke that down into multiple different Lego blocks that we're putting together to create the next generation of NFT solutions. And nestable Lego, or ERC 6059, is one of them. So in essence, it's NFTs owning NFTs, and we could just wrap here and call it a day, but it's so much more. So the standard defines parent-child token relationship, where tokens can own other tokens and be owned by other tokens. This means that a token can be a parent NFT owning other NFTs, their child NFTs, but it in turn can be also owned by another NFT. And all of those nested tokens are then governed by the owner. So be it an externally owned account or the smart contract owning them. So the standard itself extends the utility exactly by this, by defining how tokens can own each other, how these interaction and management of these interaction happen, and how they're transferred, how they're nested. Whatever can happen between those tokens is defined in this standard. So this really provides some kind of limitless potential, because even if currently you can nest tokens can really be expanded even further. They can be expanded to abstracted accounts or smart contract ownerships, or if you have the given token, you gain certain access control rows for the smart contract or decentralized organization, or what have you. And we designed owner-focused patterns in order to guard against spam, unwanted, and malicious tokens. So we always kept in mind that if you mint a token or if you buy a token, you usually end up with several other malicious tokens in your wallet that you have to ignore all the time. So we didn't want you to, once you nest a certain token into your own token, to have 5 more malicious tokens nested into it. So we designed the whole process of nesting with this in mind. So let's take a look at some of the use cases that we envision for this ERC. One is bundling. So you can disseminate related tokens as a single unit. And this is quite important, because you can either create NFT collections. So this would perhaps be an art collection that you auction off as a whole. So you don't auction each individual token, or you don't need to do some custom mechanics where you then transfer 10 tokens one at a time. Rather, you can nest all 10 of those tokens that belong to the same collections into one token that you auction off, and all of the 10 tokens will also be auctioned off with it. So when the token is nested, it actually moves with the parent token. Whatever happens to the parent happens to the child token as well. So this can also be then used in music, for example. If you have a music album, your top parent NFT would be the album, and your child NFTs would be each song individually. And this works really well with multi-assets. So ERC-5773, where you can have multiple assets to the token. And so the album itself has a cover and metadata, and then it has song nested, which in turn has audio file and lyrics and metadata as well. Steven, do you want to take the next one?
Okay. Okay, so another thing you could use it for is for collecting. So for instance, you may have different collections which are different type of assets. For instance, I don't know, I'm imagining there are collections for, let's say, different kinds of animals. So I have a collection for dogs and one for cats and so on. And I could send them all into a zoo NFT or a house NFT, which will contain the pets or something like that. So also, for instance, if you have an album, like Panini albums for the FIFA World Soccer Cup, this album could be an NFT which would receive the single cards as NFT too. So it also opens this possibility of collecting. One of the next one is one of our favorite, I think. It's Soulbound NFTs. So Soulbound nested NFTs. So when we combine this EIP together with 6454, which is in last call and should be final in the next couple of weeks, we get this very powerful concept of reputational NFTs, for instance, is one of the most obvious use cases. So each user may have an NFT, which is like the place where he or she would hold all its medals or the reputation he or she has gained on his contributions to the Web3 or games or whatever. So all these can be kept together under a single token, which is not transferable. So this opens this opportunity for reputational NFTs, which is something we are seeing growing in interest. And in general, under different conditions, you may want to have an NFT bundled to another. For instance, in a game I'm developing, there is this concept of a Soulbound gem, which is attached to the character, and it's there for good. It cannot be removed, or the character will have to die, for instance. So it opens possibilities for gaming mechanics as well. The next.
Yeah. So one of the more important thing that we might not have mentioned yet is that nesting can be done inter-collection. So the collections themselves do not need to be related. You don't need to specify that collection A can be nested in collection B. If you implement 6059, it already works. So let's jump into the next use case, which is membership. So DAOs oftentimes use NFTs to denote membership. And if you have it, you are allowed to do something within a DAO. And if you have a DAO that grows and maybe splits itself into multiple subgroups that are in charge of multiple different things, then you can nest specific access to the subgroup to the original DAO membership. And this could work well with Soulbound, but there is also another possibility that kind of ties into unrelated collections, that is that you might want to create a new DAO because a subgroup grew big enough to kind of splinter off from the original DAO, and now they have their own membership NFTs, but you can still kind of nest that one into the original DAO membership because that's where it originated from. And yeah, delegation kind of ties into the membership use case. So currently, most of the votes within DAOs are tokenized with ERC-20 voting tokens. So the way to kind of delegate your voting power is to transfer your tokens. But if you were voting through NFTs, and these NFTs can actually be reputational NFTs, where the more reputation you have within a DAO, the higher your voting power. You could also nest your voting NFT within the person that you're delegating to. So they can vote for you, and with custom mechanics, then you can get your token back without much hassle.
Okay, and lastly, there is scarcity and multi-use prevention. So one of the common use cases we've seen in NFTs is that they are used as login keys, for instance, for a game. But if a collection is used for several things, for instance, let's take the example of the Bored Apes, which are very popular. So if several people decide that owners or holders of these NFTs will be able to access some web page, some platform, or some game, then you as the holder can use it at the same time for several things. So you could be using the same token to do a lot of things, which may sound interesting, but it may also not be the purpose of the issuers of the collections or the creator of the platforms. So with this, one simple mechanic that you could implement is that, for instance, if you have a game which has lands on it, like a metaverse, then you may require the characters, the NFTs, to be nested into the land in order to use it in your game. So this forces the holders to use them only once at a time, as a real world asset would have. And yeah, basically it creates that also scarcity, because for instance, let's say I have a collection of weapons, which is also very famous and can be compatible with multiple collections, for instance, using 5773. So if I can just use it at the same time on several characters, it makes it less scarce, right? So if I add this restriction that I need the weapon to be nested into my character in order to use it, then the scarcity multiplies, because now you really need to have more of them if you want to use them multiple times. Okay, so as with for the other EIPs we have presented, we provide an npm package which you can just simply install with npm on Yarn and have all these contracts available. So in this package, you will find the interfaces, core implementations, which are non-opinionated. So things as minting, for instance, are not implemented. We have internal functions for them, but not external, because it's up to your project. How will the minting work? This is very common also on ERC-721. So we are following the lead here of OpenZeppelin, which provides all these different levels of the interface, a core implementation, and then an opinionated ready-to-use implementation. We also have this for nestable EIPs inside our package. So on the opinionated implementations, for instance, we have 3 different ways you can do minting: either lazy minting by a native token or a custom ERC-20. So tokens are minted as the users buy them, or you could also have pre-mint, where the owner and only the owner will mint for free all the NFTs first and then put them into sale in the marketplace. So all this is in this package. There are already multiple projects working with this nestable EIP and the others. For instance, Snake Soldiers, which is one of my projects, and Everloot. They are both games which use these nesting mechanics to nest either gems or weapons or armor into the characters. And there is also a short-term rental Dapp, which is called Bomba, which is using nestable EIP together with 6454 for Soulbound NFTs to create reputational badges. Well, we have a ton of tools for Dapp developers. So we have all the documentation. We will share the links for all this slide after that. We have a link tree with all this, but basically we have extensive documentation for each of these Legos. We have video tutorials where we follow the creation of a project using all these EIPs, and we explain and share all the code that we use. It's an open GitHub, so anyone can access and see the code. We have some sample journeys where we take very specific and simpler use cases. For instance, I don't know if we have it, but we'll probably add it soon. The example that Jan gave with the album and then the nested songs into it. So we take these kind of samples, like really small ones and specific ones, and we go step by step how you would create the contracts using this package and how you would interact with them using TypeScript and ethers. We also have a GitHub template which you can fork and has all you need to start working on your project. It uses Hardhat. In the future, we plan to add also one for Foundry, which is getting more traction. And basically the thing we offer for Dapp's developers by using these EIPs is that they get forward compatibility. They don't need to know in advance everything they want to use because they can be compatible with any collection in the future by following these standards. Okay, so one of the things that we want to see in these calls is how these EIPs differ to other ones. So actually there is no other EIP in final or even close to, I think, that has these capabilities. We have seen some in the past, and there are other in draft or Staniant. So why is this EIP 6059 unique? First, because it's fully focused on NFTs, owning NFTs. So we have seen others which try to solve multiple problems at the time. For instance, there's one, I think it's 998, which actually tried to do like 4 things. It was 4 different interfaces. So tokens that could own other tokens, and then tokens that could be owned by other tokens, and also ERC-20s, NFTs that could hold fungible tokens. So we are focused specifically on NFTs, and due to this and to the over, I think, 6-7 months that we played with this on EVM, testing for security and for holes and for limitations, we really have come up with a really good product with a really minimal but powerful interface that can be extended into several use cases. And I just want to remind you that even before these 7 months of development and then like 4 or 5 months of review in the forum, this concept of NFTs nested into NFTs was tested by our company in a Kusama network with another implementation, non-EVM, but we really see it worked really well. Hundreds of projects, I think, use them. So the next step was going to EVM. So I extended a lot in this first point. But then other features that makes us unique is that we have virtually unlimited nesting. So you can really easily create multiple levels of NFTs owning other NFTs, and you can get a clear direct ownership. So you don't have to do extra calls, account abstracted account or something, which the NFT owns, and then this owns the NFT. No, it's the NFT directly owning the NFT. So you can really go through the tree very easily. We can, in the implementation we provide, it's loop safe. So one thing that you could have is that you, by mistake, send an NFT to its parent or to some grandfather or grandfather. So we actually check for this, which makes us go a bit against the second point of virtually unlimited nesting, because we cannot check unlimitedly. So we went for, in the implementation, we went for, I think, 100 levels. So we'll check up to 100 levels to make sure you are not nesting an NFT into one of its ancestors. And if we don't, if it still goes and there are more owners before we reach to an AOA, then we will revert. So the implementation, it's loop safe. And something very important, which Jan already mentioned, is the anti-spam mechanism. So this is something that was, I think, a bit. So some people were having doubts about it. It was a bit controversial. Controversial is the word I was looking for, because in many cases, people will want to just have collections that can directly receive NFTs without having to go to the propose accept mechanism that is part of this NFT. So our reason to do that, well, Jan already explained, we want to prevent spam, and we want to prevent especially security attacks, because maybe you receive an NFT into yours, and when you're trying to transfer it out, you're interacting with the other contract. So we have this in mind. So we have ways to abandon or reject an NFT that was sent to you without interacting to it. So basically the parent will forget that this child exists. For the child, it will still be owned by the parent, but it's no longer an issue, and you will not see it in your wallet. So, and in the case, because we have seen these cases, obviously, where you want to auto accept some collections, because it's usually like that, you can easily use the hooks that we provide in the implementation to check, for instance, if it's from a custom whitelist of collections, you will directly accept it into the active children, bypassing the pending children. So it makes the flow easier for the users, for the holders which are using these NFTs. And it's doable, but by default, we went for safety first. So unless you do a custom implementation, the NFT is proposed, and then the owner has to accept it or not. And one of the really important things where we're also different to others is that this is parent governed. So we tried different approaches where it was we tried also like doing it from child perspective, that it was the child who had power over the parent. And we tried multiple combinations, but in the end, after months of testing and looking for flaws, we came with the conclusion that it needs to be parent governed. It needs to be only the parent, the direct parent of an NFT, the one who can manage it. Otherwise, there can be sneaky ways of using it. So this is an important concept for us too. One thing we wanted to make a bit of clarification isn't this transfer child method. This is a very powerful, and it's core to our implementation, because it allows you to do different operations. This is how a parent NFT can manage its children. Okay, so among the things it can do, it can reject a child. So remember, we have this propose accept mechanism. So NFT is proposed into mine, and I can either decide to accept it or reject it. If I reject it, it's this for operation. So the child was pending, and I will send it to null address, to address 0, and to destination ID 0, because it's not going to an NFT. You can also abandon a child, which is basically the same, but when this second child was already accepted. So the difference is that you will call this function with is pending equals to false, because child is in the active set, but it has the same effect. The child is forgotten. Both these two methods have in common that they do not interact. They don't try to interact with the child NFT. They just remove it from the pending or active list of children. This is important for security. You can also unnest a child token, which would be the third case, where you would send toward the root owner and with a destination ID of 0, because the destination is not an NFT. You can also transfer it to another address or an ERC-6059 receiver by specifying the address and no token ID, no destination ID. And finally, you can directly transfer a child token to another parent, to another NFT, by setting the destination collection as the 2 and the destination ID to the ID of the destination token. And on the other side, it probably will need to be accepted manually by the holder, unless it has this auto accept mechanism that we discussed.
Yeah, another cool thing is that we can use this to transfer the token normally. So in a sense, if you use destination ID 0 and you send it to end user address, it behaves similarly to an ERC-721 transfer. And this is something that was also really important to us when we were designing the proposal. So basically that if you are able to interact with a ERC-721 NFT, then you can interact with this. You might not be able to transfer child, so to do nesting operations if you don't implement 6059, but you can still transfer and receive and sell it on the marketplace if you want to. So this is something that's really cool. The nestable tokens can already be sold on the marketplaces. So that's what I think is cool as well. So the EIP process for ERC-6059 was a bit different from 5773, because this time around we already seen the differences in the EIP process, but we still needed to try new things. So one was the mermaid diagrams that Stephen actually showed on the previous slide. So when you write them in Markdown, they render just as on the previous slide, and they show up on GitHub. So when we opened the PR, everything looked okay. Well, once it got merged and it got added to the site, only the Markdown code was shown and it wasn't rendered. So we needed to fix that. And then, so one of the things that we usually do, I mean, I think we actually always do it on our proposals, is that in rationale, we kind of do a number list of things that we considered while designing this proposal. So the issue here was that, again, while it looked okay on GitHub, when published, all of the items in the number lists were numbered as one. So we needed to kind of did a hacky solution for that. I think that the only thing that didn't end up looking the way we wanted it to was the spacing between the entries. But all in all, I think we're still happy with the results. So that was nice. And one of the things that we noticed also is that it took so long for us to get from the PR to the draft stage that we already got questions on the discussion thread about why people cannot find our proposal. Because I actually remember, so we opened the PR on the 22nd of November, and the question got asked on 22nd of December. So there was a month gap that our proposal was still in limbo. But yeah, once it got merged, there were no more issues, and it was a learning process. So right now we usually manage to get it merged into drafts in less than a week. So we're learning.
Before we go to this, there's two things that I would like to mention, two caveats that I just realized we didn't put into this presentation. The first one is that, well, it's included in the security considerations, and all this I'm saying, it's part of the ERC document, but it's important to highlight. First is that you need to be careful if you're implementing, for instance, a marketplace which has support for this kind of tokens, because it could be that I put into sale an NFT which holds two very valuable NFTs, for instance, and just before selling it, just before the buyer accepts the deal or hits buy, I could remove one of the childs or of both children and make it a lot less valuable. So the other party would be getting less than they expected. So it's important to keep that in mind. For instance, in our marketplace, we do it. What we do is that when we hit buy, we send a list of expected children to be there. And if it doesn't match, it will revert. Just an important security consideration for your users. And the second one is that we had to forbid the use of token ID 0. We also got some complaints by this, but it really made everything much simpler and cheaper. So one of the things that drove this implementation was also gas savings. If you see in some of the, for instance, in the accept child method, I think, and the reject child, we not only request the contract, the address of the child and the ID of the child, but we also request the index from the active or pending list. So this might seem redundant, and it is indeed, but the thing is, we couldn't live with just one. I think initially we just had the index because it's the cheapest thing. The easiest way to implement this proposal is to keep a list of active and a list of pending children per token. So the easiest way to delete one is, if you're familiar with EVM, is not to look for it and match the address and token ID combination, but to just go directly to the index where it is and swap it with the last element, because it's just two operations. You swap one and delete the last one. This is how you would handle this usually on EVM, because otherwise it's very expensive. So the thing that could happen is that this list could change in the middle. So before doing operations like accepting or rejecting or transferring a child, it could happen that something else goes before. So you would be transferring or accepting the wrong NFT. So we also needed to include the contract, the expected child contract and token ID, to be sure that we're transferring or doing whatever operation with the right token. And the reason we cannot just do that and omit the ID is because otherwise we would have to loop through the entire list to search, which would again be super expensive. So this was something very valuable from the forum, and it might seem redundant, but this is the reason. Something similar happened with token ID. We discovered that it made things much simpler to assume that when you got the direct owner of an NFT had a token ID of 0, it meant it was not owned by an NFT. And this is simpler on EVM, also a bit technical here, but if you're familiar, if you get, for instance, if you have a mapping where the value is an integer, or if you try to get for the value for a key that doesn't exist, it will default to 0. It will not revert, but give you 0. So this could, unless you were very careful and our implementers were very careful, this could lead you to believe that this token was owned by a token with ID 0, which exists in some collections. But we saw this as very dangerous, and the way to prevent it was very expensive. So we just decided to do this also controversial requirement of not allowing token 0 in our collections. We also were asked, like, for instance, in case that someone wants to migrate a collection into this standard, what they can do, and the solution we are creating is that you can wrap the collection and then wrap tokens individually, so you get all this functionality. And in the case of token 0, since we cannot have it, what we will do is we will map it to the max supply, because it's the last token that if you start on 0 base index, that wouldn't exist. So it's like a trick that we would suggest there if you want to upgrade an existing collection, which uses token ID 0 into any of our ERCs.
So another thing that we also could consider is contract check, but that is at the same time not secure because it can be manipulated, so the smart contract can return the false for that as well. So this also kind of falls into why we picked ID 0. And another thing for marketplaces or anyone transferring the token to consider is that once you get the parent token and its child tokens reported by the parent token, it's good practice to validate from the child as well. So to validate that the parent token owes it, because if you have a malicious token, it can report false child tokens as well. So another thing to consider. So this time around, we also prepared the link tree, which is the same with additional resources. So it's linktree./erc.remark, RMRK. And it includes all of our proposals, ERCs, as well as EIPs. It includes links to our additional resources, so learning resources, development resources. So these are documentation of our EVM package and subsequently of our ERCs and EIPs, our template.
GitHub template.
Yeah. And Steven's video tutorials, where he used all of them, and I think a bit more goodies, but really just a lot of information. And yeah, that's it from us. Thank you again for having the opportunity to talk about 6059. And if anyone wants to reach out to us, we are JA_Jan_Turk and StoicDev0 on Twitter. So we're also available there to answer any questions that anyone might have.
But I'm sure Pooja will have some interesting questions for us.
Yeah. Looking forward to them as well.
Thank you. Thank you so much for the presentation. I mean, it was really, really great. I really like the way that you guys have explained nestable NFT, like NFT in a tree. People love trees, I guess, in cryptography. We have Merkle tree, Patricia tree, Merkle tree, and now we are going to have NFT trees. So that's quite interesting. Well, learning about the thorough testing that the team went through, testing up till 100 levels, that was incredible. And the resources shared, I'm sure they are going to be valuable. The first time when I learned about the NPM package that you created for the earlier proposal, that was great. I'm hoping the package shared for this proposal will also be helpful for obviously the hackathon participants and students who are looking forward to learn these proposals. So thank you so much for putting all the effort into it. And yeah, I really appreciate the EIP process feedback. We'll take it with some grain of salt. I understand the process wasn't perfect and it is still not. We are trying to improve it every day. We have recently added ERC editor and EIP editors as well. So we hope the process will be smoother in future. But thank you for bearing with us. I do have a few questions for you while going through the presentation. Some of them were already answered, but a few more probably to add some clarification. Nesting, as we can see with this presentation, that has a lot of advantages. I wonder if there are any compromises or concerns with the proposal that people should be aware of. Do you think it is going to increase the cost of NFT, maybe because it's making the contract a little heavier, or maybe because of the high gas?
One is definitely the ID 0 that we already mentioned, and we also mentioned a kind of small list of security considerations that you need to keep in mind. And yeah, another thing is that we are extending 721, which means that your smart contract will be bigger if you implement it. So deployment costs will be higher as well.
Yeah, about gas, we were actually very careful about this in our custom implementations. Well, actually in the core non-opinionated implementations and also on the ready-to-use implementations. We really did spend several, I think tens of hours in reducing gas and reducing size. Because when you start adding and stacking up all these Lego EIPs, you start getting uncomfortably close to the 24 kilobytes limit for mainnet. But for gas, we have checked these operations. Like when we run our test suite, we get a report of the average gas, like min, max, and average gas used by each of the operations. And we found that in all cases, these new operations that ERC-6059 adds are very close or like very similar to the cost of transferring or minting an NFT. So of course, there are more operations. So if you want to do more things, well, you need to pay a price, of course. But it's not like it won't be an order of magnitude higher. At least we are sure of that. They are at most twice as expensive. The most expensive operation could be at most twice as expensive as a transfer or a mint. So we don't expect this to be a problem.
That's good to know. Very well. So another question which is slightly related with it when we are getting into this nested NFTs, you did mention about parent governed security feature that is added to this proposal. Do you think, generally speaking, nesting increase the vulnerability? I understand that NFT can be parent and it can also be child. So if it is a parent, that means it will have the governed security, but what would be the level of vulnerability that it will be exposing to hackers if they are trying to target one level?
I think besides the possible issue of removing children before you sell them or something like that, there is nothing new that we add, because that's the actual reason why we picked this model of it's the owner, the parent NFT, the only one who can do operations on this one. Even if you approve this token to be managed by some marketplace, but then you send it to another token, then there's no approval valid here. Only this one can interact with the child and transfer it and do approvals and anything. So, and yeah, this token can be transferred to another one and it becomes a child and a parent at the same time. And in that case, it's the new parent who has the full ownership and the only one who can handle it. So as long as you don't send your NFT into a vulnerable collection or a malicious collection, you should be fine. But that is important. One, to clarify, if you send an NFT to another, you are effectively giving away ownership. It's now that other NFT who is the owner. And if you send it to an NFT from a collection that is malicious, that for instance has a backdoor to transfer children to another address, then it's your responsibility. Just as if you interact with a marketplace and you approve a marketplace, a malicious marketplace, to sell your contracts, you can just steal them. Or if you approve your ERC-20 token on a malicious swap site, it can also steal your tokens. So I don't think there's nothing besides that. Besides, make sure you don't send your valuable NFTs into a collection you don't trust.
And don't accept tokens that you didn't nest or didn't expect to receive.
Yeah, totally.
Right, that's very important. While talking about sending, receiving, you did mention about this proposal being useful for intercollection, right? I remember a proposal which was there for multiverse NFTs, and the number is 5606. So I'm trying to understand here, like when we are getting into this nested NFT concept and we are trying to send the entire set to a different multiverse, will it act exact the same way, or will there be any feature change or properties change we are expecting?
But it's about bundling. So I think what this does is like you can create, like you merge or bundle multiple tokens into a new instance. So that's a huge difference there, because you create a new concept, which is the bundle. Whereas in our case, there's not new things. There's just a new relationship. So you don't need to have a special handling of bundles, because if you know if a marketplace or a Dapp already works with 721s, it will work with 6059. It may not show the children if it doesn't implement this EIP yet, but all the other operations are transparent. I don't think it's the case for 5606. Sorry to interrupt, Jan, but I was just looking at it.
Yeah, no, that's okay. So from what you described, comparing the proposals, ours is like putting bricks on top of one another, and they're nested in the sense that they create a whole, and the other one is adding mortar to them, so you cannot really pull them apart anymore.
Or actually, maybe you can, because I think they have an unbundle, but still, it's a different concept. It's a new thing on its own. Whereas here, it's the same two parts. They're just NFTs with a special ration.
Right, I believe like whatever suits the most for an application, people have standards to pick up with. So yeah, that's there. Talking about this NFT, like nested, we learned about a proposal which was hierarchical NFT. I'm trying to look at the number. Yeah, the number is 6150. So how would you say this proposal 6059 is different from hierarchical NFTs, which is, I guess, in the final status right now?
Yeah, I remember this one. So if I remember correctly, this is specifically for NFTs which can be nested into the same collection. So this is a huge limitation. It may work for some use cases. If, for instance, if you create NFTs are folders, then it makes sense that they can only be nested into folders. But if you want to send this NFT to another collection, it won't be possible. So yeah, it's a huge difference there.
I have a question from the Fellowship of Ethereum Magician page. A few days after being final, the proposal received a comment by a user, Midnight Lightning. Apparently, this proposal doesn't fit the definition of what is backward compatible. I'm wondering, what are your thoughts on it?
Yeah, we also saw the comment, and we realized what it's about. So if you have an ERC-721 token, you cannot nest it into a 6059, because ERC-721 doesn't have the required tools to be nested into a token. It's meant to be owned by root owner. That's what we call the top level owner that can manage all of the tokens. But what we were referring to is that everything that exists out there, so the toolings from packages to development frameworks, from chain explorers that can now present NFTs to marketplaces, everything that's compatible with 721 will work with 6059, but the tokens themselves won't. So this is where we kind of stepped apart from the backwards compatibility. But we really put much thought into how we can be as close to 721 as possible, and some conventions even are reflected in this way. So minting, for example, isn't specified in 721 either. Neither is burning. So we omitted those from our proposal as well. We really made sure to kind of follow it in a sense that we don't modify it or override anything that there is to just add new functionality. But yeah, I mean, it's not 100% backwards compatible if you consider the implementations, but if you consider everything else that comes with 721, then I'd say we're 95% there.
Yeah, but and it was actually this guy you're mentioning, he did really interesting comments in this and other of our ERPs. He has been a great contributor, and he has pushed us to improve, for instance, the immutable EIP, which is 6381, to be much better and to make sure that it will be used for the 100 years. But here, actually, we intend to do a minor update to reflect this, because it's I don't know, it comes down to semantics. I think the way we envision it as backward compatible, but we understand his point in that aspect it is not backward compatible. So we will update to make sure it's clear. We just haven't had the time.
Yeah, I mean, when you get someone like this commenting on your proposals, you're not even mad that your proposal is not finalized for another month because the improvement is so great. Speaking of immutable, so 6381.
Absolutely. I totally agree. And that's the benefit of having this one central place for discussion. We let people know that this is a place where you can share your feedback, where authors will read them and probably will implement them. So it will be better for us, for other project implementers to get the better version of the proposal that we were expecting earlier. And keeping the proposal close to 721, I think that is a good thing to have, because most of the project developers, they start from, if the proposal is about NFT, they start from 721. So closer the extension is, it will be easier for newer developers to follow through. So yeah, thanks for that. The other day you talked about the EIP editing office R. That was very good feedback. While I have you here today, may I get your thoughts on PEEPanEIP series? When and how did you hear about it? And will you recommend this to other authors? What are the kind of topics that you would like to be included in this?
Yeah, I mean, I really think this is a great forum on how to present your EIP. I guess it is shaping up to be, or I mean, it already is. It has more than 100 episodes. To be the place where, if you want to know what's going on with the standards and in the Ethereum ecosystem, that's where you can come and hear all about the new developments. Because beforehand, I mean, I remember my first proposal that's now sadly stagnant. But back then, there was no other way than the page, the repository for EIPs and Ethereum magicians. But that can get overwhelming if you try to keep up with everything that's going on there. It's kind of hard, and you need to read through everything. This way, everyone can. So everyone, meaning the authors, can showcase what they think is the most important part of their proposals, and I think that's really beneficial. And as for sharing this, I know I will. I actually talked to my master thesis mentor, and he asked for it to be shared so he can share it onwards as well. And to anyone that's writing the proposal, I really suggest that once you reach last call final, that you start thinking about this, to start presenting your proposal, because there are a lot of finalist proposals, and some of them are really good and way underutilized because you just cannot find it. So everyone will really appreciate you coming here and talking about your proposal.
Well, that was the initial idea of starting this series. We wanted to provide a platform for authors to be able to share their proposal and implementers to get to know the proposal even better in a simpler way. I understand to implement this proposal, implementers has to go through the entire documentation, the specs, but to have an easy to understand version, a video version is helpful in my mind. So yeah, thank you so much for the feedback, and I hope we continue creating these resources to help users of Ethereum community. Well, we are at times and we should wrap up now. Any final thought or message to the community that you would like to share?
Yeah, I'd just like to thank you again for having us, for giving us this opportunity, and to all of the Ethereum cat herders, because throughout the process we've had help from several members of your team. And I'll wrap it up here because we'll talk again in 2 weeks. So I'll prepare something longer then.
Yeah, I just want to do the same invitation to builders to go and check all these amazing tools that we are building and that other people are building to make NFTs much more powerful, and for holders and agents to ask for their collections, to look for innovation in what they are buying, and to literally ask the owners of the collections to move forward, to not stick to 721, which, yeah, it's great, but it can be a lot more than that. And thank you, of course.
Thank you so much. Thank you, Steven, Ian, for we really appreciate you taking out time to provide an overview of Proposal 6059. We look forward to see this standard being adopted by NFT projects. On this note, thank you to all our YouTube viewers for watching and ECH podcast listeners for following this talk. Should you have any question on this or any other topic, let us know at EthCatHerders Discord. Don't forget to like and subscribe EthCatHerders channel for more talks on EIPs and protocol upgrade. Cheers.